Here we are. I think we're live. I think we're live. It looked like we're live. Today is a different episode of CodeStream. Not that we're doing something different. We're still hacking code. We're still part of a. This thing is creaking in my ears. Sorry. I'll try not to get distracted by it, but it's a headphone. I'm wearing my gaming headset that I brought in from home. I'm actually in the office today. I'm in San Jose in California. I'm in the old Splunk office. There's no Splunk, but when Cisco acquired Splunk, they actually they took over the office. So this is the new Cisco office. It's one of their fancy ones, I think, because our office is pretty fancy. I think it's very fancy. I like being here. It's very quiet sometimes, though. But not recently, because we've had a bunch of construction going on the upper floors. Anyway, this is not interesting to the internet. What is interesting is HARific. HARific is a tool for analyzing and debugging and diagnosing problems between clients and servers based on HAR files. HAR files are HTTP archives, HAR. And we've been working on this for 3 days. And this first day, we put together a design. We spent most of the day designing. I'm not sure how much code we actually got done that day. A little bit, I think. Second day, we spent actually building the large part of the engine. The engine is the core, obviously, of all of this, but it's the thing that it needs to work the most. It needs to be the most efficient, and this is actually what makes this tool useful, is how quickly we can read and parse a HAR file and then make that available for searching and reviewing and scanning and things like that. So getting all of that indexed and knowing where all those response bodies and request bodies are, that's actually where the majority of the bulk of the HAR file comes from. I know I've said this before, but I'll say it again. Anyway, we spent most of Thursday. It was Thursday we spent most of that. Thursday, I know that doesn't make any sense if you're watching the video later, but that was last week. Today is Monday. That was last Thursday. And then we spent last Friday, which was a couple of days ago, going through and trying to refine the engine. So we actually, what we did on Tuesday was we actually got a little bit of UI built towards the end of the day. There's a bit of placeholder terminal user interface, and it was actually working. It was working pretty well, and working pretty well in the sense that it actually works. It loads and it has a loading screen and it allows us to scan. Does it look great? No, it looks terrible. And the code is all half sketch code, but the engine is looking pretty good. I think we've got it pretty well refined. We spent Friday trying to make it faster, and we totally and utterly failed. It was a huge disaster. Just make sure I've got my chat up here because I can't actually see what's going on. All right. I don't know if anyone's talking to me or not. Just make sure that we've got everything going on. Okay, I've got David Serrano. I see David Serrano. Ooh, sorry. I didn't have my chat up there. I was just coding away. I mean, just chatting away. Not coding yet. We'll get there in a minute. I'm not sure why. So the streaming stuff isn't coming up. You know what? I don't care. I'm just going to leave the chat off for right now because it's just getting in the way anyway. I'll leave up by. Actually, no, I do need the chat because there's people on Twitch and I don't know if anyone's talking to me. So bear with me a second while I just mess about with this for one moment, and I'm just gonna try and figure out what's going on here. So I need to click around a little bit in the background. I had this working earlier, but for some reason I seem to have messed it up a good bit, and I don't think I've messed it up. I think I've just got it off the screen. There it is. There it is. I'm gonna make that a little bit smaller because it's just in the way. All right. Sorry about that. No, you can't see what I'm doing. I just made it all live now, so I'm gonna chat up there so we can see what's going on. All right. Thanks very much for sticking with me through that. Let's get back to the fun. So with HARific, we spent all of Friday failing. We tried to make the engine more efficient by using different scanning techniques. The indexing part is fine, but really well, it wasn't fine. we've got a working model, but we tried to upgrade to the latest version of the Go JSON package. It's experimental. You can enable it through a flag and a compiler when you build your code, and we worked with that all day long. We made great progress in certain areas, so we kind of sped up significantly, but then we lost accuracy because of our scanning technique. It was we just didn't have the tools available, so we were really wrestling with the limitations of Go and with the JSON decoding, the standard library and the replacement. And if we went to a third-party fast JSON parsing and unmarshalling tool, we lose all the benefits of the speed we've already got. So it's kind of, we're taking one stick away and trying to keep the same balance, but we need another stick and we can't get this triangle balanced. It's like, do you want speed or accuracy or quality? I'm like, all three? Well, then you have to get a little bit slower. And in a tool like this, we can't give up accuracy for speed because it's just ridiculous. So that's what we're finding is when we were doing some tests towards the end of the day, it was failing a good bit with some of the requests, just because our delimiters and where our boundary checking, and we were left and right. Now we probably could get it right, later on with some sit down and really think about it. But on the heat and the pressure of a hackathon, I don't want to over-rotate on it. We already lost a day to it. A bit more time than I would like, to be honest. But at least we went through that exercise of trying to find out, is this going to be something that's useful? Okay, so where do we start today? Today I want to start. Well, actually, first of all, I've renamed the repo. It's no longer called Braid. The project's not called Braid. Although I love the name Braid, I'll use it for something else. HARific is what the name is. And you see this little logo I did this over the weekend. I actually did this on the plane yesterday. I was flying for about 7 hours yesterday, so I did a little bit of code, and then I spent a little bit of time doing this. What do you think? I think it's pretty cool, actually. I like it a lot. I'm pretty happy with it. Anyway, so today I decided to break this into two challenges, or two parts, or two tasks. Two parts of the task. The first part is going to be user interface, or the TUI part, the terminal user interface. And then we're also going to have another agent working on search. I was thinking about, I'm going to be running in Git work trees. So this is one of the benefits, or one of the techniques, or I guess the benefits would be a good way to put it. It's like when you're working with multiple agents in the same code base, you run into all kinds of problems with them stepping on each other's toes, particularly when you're changing things and code doesn't compile and it breaks off a signature while you're refactoring, and another agent says, "Oh, there's something wrong. Let me go and fix it." And then they just start fighting each other, and you end up in an absolute mess. So running multiple agents at the same time, the same code base, is usually a mess. So this is where Git work trees comes in. It's really useful. And what we've got now is we've got two different folders. We've got the branch A, branch B checked out into different work trees, and now we can actually work on those individual branches without having to conflict with each other, because they've got their own repositories. Essentially, it's kind of like a copy, but like a managed copy. And then when we're done, we can push those branches and merge them back into main, and we've got everything we need. Or when we want to take some of the search engine and expose it via the new terminal user interface, we'll have that as well. Anyway, so back to search. So we'll start with the terminal user interface in a minute, and then we'll kind of move on to search. We made a little bit of progress there. With search, and one of the things you need to, you've got this like 70,000-80,000 entries in a HAR file, and you think, well, how do I actually find what I'm looking for? I know I've got a path. I know the path and I know some of the query parameters, but I'm not sure of all of them. I'm going to look for something specific. And then, or what about, if you've got it in a body, like you've got something like a property or parameter or something in the body, and you want to look for it, and like, search becomes then something different. We've already got our index, and then we know how to load the individual request and response bodies into the memory. But how are we going to super fast search everything? So that's what I want to do with the other agent, is start going through that search engine for the HAR file, which means going through the index and building like a worker pool, and then having a queue and having everything. Like we'll pop entries into the queue. We'll have one of those workers pick it out from the pool. They'll go and look at it. They'll scan everything without necessarily reading everything into memory, because we don't want to leave. If we read all those requests and responses into memory, we are going to end up with a huge blowout memory again. Like the whole point of this tool, that we blow up all the memory, will be, pointless. So, not gonna blow up the memory, which means that we need to have a buffer to be able to have a pool of workers and a pool of buffers. Effectively, that we can pull out a buffer, pull an item off the queue. We can then go and look at it and say, is there anything in there? Does it match anything? And then if it does, then we'll send it back at a channel and say, here you go, here's a result. And then we'll collect those results and then we'll render them out. And we'll render those as maybe we'll do it real time. So like when you're typing, it's doing the search. That's an interesting. How are we going to do that? Done it before. It's pretty easy with doing the browser. I could do that. Yeah, maybe we'll try it. Well, I think we'll start easy. We'll start simple first of all. We'll start simple with just you put your search query in, press return, go to do a look, render results in the background, and then we'll add things like regex as well, so we can do some regex searches. Yeah, there's regex. So yes, let's do that. We'll get the search working right first, then we'll add the regex ability. Regex. Now, some people say regex. I know it is regular expressions, so it is regex, but I say regex. Does anyone else say regex? Like reg? I know it's reg. I know it's reg, but it's just something that stuck with me forever. Anyway, that's how I say it. Regex. 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 That sounds better, doesn't it? Regex. We should call it that instead. Much better. Much better. Regex. That's what I'm going to call it. Anyway, when I read regex, we'll add a worker pool with a queue for searching, a buffer pool as well. And we get that working, and we get the UI looking clean. I think that'll be a good round number, a good target for us to hit today. So we've got search is enabled in the UI. It runs fast as we can get it today. And then we've also got some regex in there. Regex in there. And I think that will be a good place to call it a day, because then tomorrow we can clean that all up, refine all of that, do some code reviews, clean up the mess, and then start maybe, I don't know, that's tomorrow's problem. Today I think we've got a good plan for the day. I'm pretty happy with where we are so far. I would have liked to make more progress on Friday, but we went through it. We went deep. We looked at all the options, and we discovered, well, I discovered anyway, that we just can't make it any faster. Not with the current design. We'd have to change the design underneath to make the indexing design. And I already think we're already rolling at a pretty good design. Anything else would just I don't know. So we'll leave it there. We'll come back to this. There's always room in the future to iterate on this. This isn't the end of it. We're not going to just leave it as is. This is going to be an organic entity, just like everything else that Princess Beef does. It's going to grow and be open source, and hopefully people use it and grow it and all that stuff. But for now, I think it's good enough. So with that, let's go and take a look at the code. Actually, what I'm going to do is I'll bring up. So I'm actually running off of my laptop today, and I'm not running off of my normal station, so I can't see things like I normally would. I'm a little slower. Doing the mobile streaming off your laptop whilst having the. Anyway, it's a little harder, to be honest. It's a little harder. I'm gonna do my best. So if I go a little slower today, I do apologise. And now I realise that was the wrong window. It's a terminal UI. So this is actually so what I've done is I've broken this out into HARific-2e and HARific-search as two different work trees. We're going to get the 2e kind of going first. We'll take a look at the code though, because I can't remember what the code looks like and what we built. And also I realized, I think when I was thinking about it over the weekend, we've got a bunch of commands in the terminal. I don't think we need any commands in the terminal. I think it just needs to run. So just be HARific, and then you point it at the HAR file, and off you go. It'll spin up the server in the background. The 2e will be running. There's no need for additional commands, so I think we can simplify this interface a little more, which will be great. So if we come into main, we'll go to zoom in so it's better. Main doesn't do very much except run this execute command, which is coming off of the root.go file. This is a Cobra CLI design. I mentioned this the other day. I'm not going to go into the design of Cobra, but this is effectively what we're looking at. We're defining our root command. Now, this is all we're going to need. To be honest, this is all we're going to need. I don't want to add any more other commands. I believe that we have already. Maybe not. Maybe we haven't done it yet. Root command. So let's see what we've got down here. Text handler, verbose. That's the logger. Sure, nice streamer. Oh, okay. This is actually what's setting up the engine. We need to go into that. We need to go into that code as well. We did look at it, but not in depth. I'm actually curious about. Our root command here. Go into Cobra. Curious now, so I'm just looking through this code. I haven't spent much time looking at it, so I'm doing that today. That's what we're going to be doing. First of all, is just reviewing code. I'll do my best to talk through it, but first I'm just kind of reading it a little bit, just kind of going through it, trying to understand what we've done here, how our main view is constructed. What I'm actually interested in is following the flow. So we're running our command execute, running the root command execute. And setting up a logger, which is very interesting. And what the logger is doing is these are just using the structured logger handler options. So it's we're using the verbose flag, stick it in debug. Otherwise, use the level info. Again, super straightforward. Then we get in the logger. Returns a global logger instance. Okay, it's fine for now. We'll leave it as is. And then we got the validate HAR file. So let's just define this. We've got root from there. Where else are we calling this from? View. Okay. Yeah, this is what I was kind of interested in. This is what I think that we need to get rid of, is this view command and just have it on the root command. What we're doing here is we're adding a new command off of the root called the view command. command. There's nothing in the root. The root's not doing anything except just setting up a logger. In the view, well, actually, what we're doing here is we're validating the HAR file. Validate HAR file. What is going on here? What is going on here? Validate HAR file. Looking, we're doing OS stat. Does it exist? Does it not exist? Okay, we'll throw an error. Is it a directory? The path is the directory's path. Okay, we can't use that. All right. So let's make a note of this, because this validate HAR file isn't actually doing very much in terms of being very interesting. It's just doing some very light legwork as to making sure that we kind of got a valid file. It's on a directory and it has a .har extension. I think we should get rid of that, because the HAR file could be called anything. I don't want to restrict. We call it .json. You know, I don't think .har is a good idea. Let's call it. It's just gonna check. It is not a directory. Okay. File exists and it's not a directory. Right. Let's go back to our view command. It does a validate and it throws back an invalid HAR file. Okay. We can tune all of that out later. And then the TUI handles the indexing. We had a spinner in there. So launch TUI. Zoom in here. What we do? Whoops. Where do we? There it is. There it is. There we go. There it is. We're pulling in T from bubble T, and then we're running launch TUI with the HAR file as a string. Build the model. See what that is in a minute. Can't create the model. New program with alt screen. So this is most likely going to be something very, very straightforward. Okay. All this is doing is just giving us the HAR view model, which is what's used by the bubble T, and with some bits and pieces in here. Actually, what it's doing is creating the view model, and it's putting in the columns used for table view mode, selected index, the load state, loading spinner, and then indexing message. All right, cool. Oh, that's pretty nice. I don't think we need to change that at the moment. And those are the columns we asked for on the table. So it's basically setting the table up, and it's going to use a bubble T table to render that out, which we've seen already. All right. So when we're loading or initializing the model, which actually comes from TUI, it's HARific model. What it's doing is it's setting up these commands: load the spinner ticket, and then start the indexing. Let's go and take a look at indexing. It's in loading.go. Yeah, we need to change that file name. We'll do a bit of refactoring in a bit. What this is doing is returns a function, starts a new HAR streamer with the streamer options in our motor. This is all the code we've already looked at. We're not going to go into it today, but that's our cache for future use, but we're not too worried about that. We'll leave that for right now. Let's come back to TUI, do our model, run the model, and then load the state, load did. All right, now what we're doing is we'll on an update. We've got the waiting for the index complete message to come through. So let's find where that is being sent. Here it is. And that's in start indexing. Okay. So start indexing runs async. It's starting the streamer. You can't start it with an index error. It starts with the initialize, and then that's gonna do all the work that we need to get done. That's what takes the time. We get the index, and then we return it back via this index complete message. So back in our oops. Back here, let's go back. Where were we? Lost our point, lost our view now. Come back here under loading view. I'm going to look at the loading stuff before I start getting into the actual main view. But back where we were. So now we do our updates. If it's loading, keep the spinner loading, keep that going, and then we get these different switch states. We change is model. So on the model we change the state, we'll add the index, we'll set the streamer, the number of entries, and the indexing time. So we know how long it took. We've got the index, we've got all the bits and pieces, we change the state, and then what we do is we initialize the table and render it all out. There's an error, do an error. If we're changing the size of the window, we need to update the dimensions, the table, the viewport dimensions. We need to look at all of that. This is to make it responsive and make it render correctly based on the size and the width of the terminal. And then we've obviously got our key commands. Well, we need to come back to this at some point soon, later today, I think, to tune these up, like Q, Control C, Enter, Return. We need to add in search capability. We need to add those as constants as well. I don't mind that. And then basically on the state of the model, you decide. You decide to what do you want to view? What do you want to load? You've got the loading view. You've got the quitting, return nothing, initialize table. All right. So once we've done the index, we can get rid of the loading spinner. That state is changed, and then we can initialize the table. We need to bring in those columns from the model we've already set. The height and the width comes from table vertical padding, which is going to be a constant. We are going to have to come and tune this up at some point. This is going to need tuning. These are always too thick and fat for my taste when it comes out of an LLM. And what we're doing here is calculating the table height. Then we have a table, and then we have a little wrapper called apply table styles to the table. Let's take a look at that. This is in styles.go. That's too big. Alright, so currently using the default white styles. It's not vacuum themed. It's not bit white, bro. Bit white. Alright. Apply table. Oh, it is vacuum. I'm copying vacuum, but it's from PB2FF. So you apply the table styles, which is none. We just do the default styles. Alright. And then we've got a bunch of these are helpers to determine what. I don't think these are working properly yet. They're not even being called. There's no usages. There is one usage here, but I think it's only in the comment. Get rid of that. Yeah, we're not using these colours at the moment. not using any of this except for a few of these, which I'm not sure why I put those in. Got styles. Again, I have to change all of these. I think these always like well, no, they're right actually. The red, blue, salt pink. Right. Keep an eye on that. So I'm just looking over here, checking on a few things. Bear with me, chat. I'm just looking at stuff on the computer. I've got my work stuff isn't like there. Something is buzzing. Something is buzzing. I'm not sure what it is. Right, okay. Alright, cool. I hope everyone's following along. I hope everyone, if there's anyone in India who's watching, hello. What about Poland? Anyone in Poland? Hello. I'm not sure. Alright. These are our lip gloss styles. We haven't done any of this, work with any of this. Lip gloss, if you don't know what lip gloss is, this wonderful library from Charm that creates ASCII codes in the same API as you would fit programmatic CSS. So think of it like that. It's programmatic CSS, but there is no CSS. It's all done through ASCII codes. That's the only way that you can color your terminal, right? Color the string. It's all strings. You're just rendering strings. It's colored strings, effectively. So, provides this really nice, clean way of defining styles and applying them to individual like borders or layouts, so you can use it like CSS, but it's not CSS. But in the design or the vision of it is to be like CSS, but it's not like it. But it is there in its in its soul. Okay, there's nothing to really go through in the styles. Let's go back to our table. We got our dimensions. This is updating the viewport dimensions. Don't need to worry about these just yet. This is all pretty mechanical. It's just looking at the height and the width and determining how big to make everything based off of the terminal window, how many columns are being rendered, things like that. And then we've got a split view. So toggling this split view, this is actually gets hit, and when you hit return, it's going to fire that command, and it'll get hit, and that'll then open up this split view. If we go back and take a look, you'll see that on the enter command, what it's doing, if it's loaded, toggle the split view, I open it or close it. And with the split view, it returns the table, and then we've got that request and response on the bottom, on the left and the right. That's fine. I mean, this is all pretty clean. It's all pretty clean, to be honest. We're going to go in, and they're actually going to go and define this split view, this viewport dimensions thing. We'll go through and tune all this up, probably with AI, maybe manually, depends on how badly it messes it up. A lot of this stuff usually generally pretty good to just let the LLM deal with it. And then you think like adjusting the column widths, sometimes it gets the math wrong, sometimes it puts magic numbers everywhere. You've got to go and clean all of that up. And then we've got loading the selected entry. So we look at the selected index, and then we basically just pull that straight out of our streamer. That get entry is going to then go and do that decoding on that body and pull that all out. And that's going to suck up as much memory as is required to deliver it, but we can't do anything about that. And then we put the selected entry to entry, and then we update the viewport content. That's it. I think that's basically it. I think it's all pretty clean. It's all pretty clean. It is all pretty clean. The logo is... Sorry, I just saw your chat there, David Serrano. Thank you. Thank you for that. I appreciate it. That was all AI, by the way, except for the text. The text, I did the text. That was me. That was my own text skills in Photoshop. But the rest of it was AI plus Photoshop. Tuned it, glowed it up a little bit. In fact, that's 99% of graphics I always do. Is I just take a piece of stock R or stock vector, and then I tune it and change it and hack it. I just hack it, I modify it, I grow it. Now, if it's commercial, it's free. I mean, it's free for me to do that because I paid for it. If it's free, I usually try and put a kind of reference back to it, or I modify it so heavily that it's nothing like the original, and effectively all copyright is destroyed. But I use it for inspiration. Like, for example, once I was creating a robot, and became this. It was all over the branding, but I started with a cockroach. I started with the design of a cockroach. It was a cockroach. I'm not kidding, it was a cockroach. And I modified it so heavily and turned it into a big robot. It was completely unrecognizable from the original. I do that a lot, hack. I hack design and I hack code. To be honest, there isn't a lot to this. So let's remind ourselves of what this looks like. It's not braid, is it? Is it terminal 1? Terminal 1. Terminal 2. Terminal's mixed up. Sorry, I'm saying hello to somebody. Hello, Sarah. Hello. All right, got my terminal up. All right. Am I in the right folder here? Let me just make sure I'm in the right directory. Where am I? I'm in the wrong folder. I think I'm come out of this. We go into HARific. What is it? 2E. There we go. 2E. Now we're in the right work tree. Okay. Oh man, we got here main doc. You know what? It's annoying the crap out of me. All right, I want to move it again. Let's build it. And if we just run HARific, yeah, it's just nothing. We're still with the old braid as a terminal using the base, blah 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 blah. Right, and then we're going to put this view in here. So maybe the first thing we'll do is we're going to get rid of that view command because it doesn't need to be there. It should just be. Where's the? Do I need test files? What's the test files in it? Maybe I deleted all the test files. CMD. Oh no, they're in HARgen, aren't they? Oh, we didn't generate any. Let's go and build that. I think I deleted all this stuff the other day. While I was cleaning up. All right, let's go and build this bad boy. Go build. Let's get this. Another main dot go. It's annoying. Let's just change that. Main to HARgen. I don't need to do that, do I, if I'm doing this? Hack. There we go. HARgen. HARgen. Alright, generate a HAR file, 5 megabytes. Oh, where did you do it? Where'd you build it? Test 5 MB, alright. Test. Okay, we got our file in there. Right, HARific. View chest. There it is. Look at that. 65 entries loaded in 14 milliseconds. That's good. That is good. No, I'm gonna do it. I want a bigger file. 5 megabytes is just stupid. We don't know. Nothing's 5 megabytes. Let's do 500. It's half a gig. That's a reasonable test, I think. I can't remember. We didn't put. You know what? We didn't put any bloody commands in there, did we? Take a look at HARGen. Now we're getting into it. What have we got? Blah, 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 blah. Methods, statuses. Size, alpha seed. Okay, so we want dash size, and then we need to put 500 MB. Okay. Look at that. There we go. Great. Great. No. Idiot boy. There we go. Got that. Great. Now we've got a real big one in there. Let's have a look at that. Let's test that out. There it is. 500. 1000. 2. Ooh, 1.3 seconds. Okay, I'm gonna take it. I'm just gonna take it. It's so fast. But half a gig. That's fast, man. That's fast. I'll take it. So this is what it looks like. Been through the code, nothing special. That's the split view that comes up. And scrolling up and down takes control of the split view, and hitting escape will bring us back to the table view and close the split view, which means we're just rendering the table and not the split. Now we've got the split view, comes up over, brings it down. We need to fix the sizing on that because those panels are the wrong size. But in a nutshell, that's it. You know, then we would have like a I don't know, a keystroke to bring up the search box, and we'd bring up a search box to do the search, so we need to flip over to the search in a minute and get that rolling. But before we do that, let's get one agent rolling on getting rid of the view command, because we don't need it. We don't need the view command. We don't need any commands. It can all be run off the root. And then once we've got that in there, then what I want to do is, what do I want to do next? Looks rubbish on this. Let's figure out why sometimes this request and response is rendering a different size. If you see that the right box is a different size. It's the first cosmetic issue that I'm seeing. Like, I mean, there's loads, but like, it's wrong. Like, that is wrong. Content is wrong as also. We need to tune that out. But let's do that. Let's do the command consolidation first to clean up the workspace. We don't have to come back to that later. Get it running the root command. Then we'll figure out why this is right, and that's right, and that's right, and that's not. That's, if you can see down and the bottom and the half here. I can't see my mouse. I've got the cursor disabled, but the right hand side box is taller, i.e. the left one is not filling up all the available space because the body's empty, but we need to have a minimum size on that. So, you know, if the body's empty, it'll still fill up the space. So that'll be the second thing. And whilst the LLM is working on that, we can flip over to search and start thinking about what we want to do over there. All right. So let's quit out of this and this could be challenging, so I need to have another terminal. So I have 2 agents running in 2 terminals, and I need to have another terminal. And now I got to build another terminal live. We need 3 terminals so we can actually see the application. But agent 1 and agent 2, and then we need. Oh, all right. So whilst it's doing that, while we get this rolling first, then I'll set up another terminal so we can actually view the TUI, see agent A and agent B, and I can try to remember what the hell I'm doing in terms of swapping these all around. I could just share my screen, but you know that's even messier because I'm flipping backwards and forwards. So yeah, I think this will just have to do. You have to just bear with me. Bear with me. Now we'll leave this. Never mind. I'll set up another terminal. Still the wrong. This is the wrong one. This is the wrong terminal. This is the wrong one, mate. In the wrong one. What is going on? How many terminal windows do I have? Oh, I've just closed the terminal window. I'm in total India. I've just broken it. That's why. You have to bear with me. I've just closed my actual terminal by mistake. I didn't mean to do that. Now to go and fix it in the stream. Sometimes it'd be just easier to just share your entire screen, wouldn't it? Wouldn't it? Wouldn't it? Wouldn't it? But no, not me being an idiot, of course. Being an idiot. So I'm just trying to rewire up my terminal here. Okay, there it is. Hello. Okay, good. All right, I did that live. Great. So I'm just gonna keep it live so you can see what I'm doing. We are in the wrong directory again. It is HARific TUI. Let's fire up Claude. Oh, not Claude. Claude. All right. I'm not sure if you can hear the sound effects coming through, but I'll leave them on anyway. Tell me if, chat if it's annoying. Okay, Claude. Today we're going to be cleaning up some of the Cobra CLI and terminal work we were doing last week in HARific. So, oh, I got it. Spelled it right. Actually, I'm just going to change my mode on this. All right. Okay. So we're cleaning up some of the code, the Cobra CLI and the terminal work we were doing. The first thing I need you to do, Claude, is go and read all the code from root and go and take a look at the CMD folder and then take a look in the motor folder. Actually, don't look in the motor. We don't need to worry about that. CMD folder. Let's make sure it is the CMD folder. Yeah, it is the CMD folder. And the TM TUI folder. Yeah. And the TUI folder. Read the code and understand what it is that we've done. All right, great. So while we've got that one going over there, let's see if we can flip over to this other terminal. All right, and then we need to go into the search. Rather work tree. Same everything in here, but it's it's not gonna have all the other stuff in there. And I want to bring up Claude again. Alright, so in this one, we start thinking about search. So I want to bring on the planning mode. Let's ask. No, we needed to. So first of all, to get context, I'm going to want it to look at the HARific engine. So go and look at motor. Okay. Hey Claude, we're working on a new feature for search today. Before I do that, I need you to go and understand our indexing mechanism and our model. Can you go and look at the code in motor for me and refresh your context? All right, great. I'm pretty sure that we put a Claude MD in all of this. Yeah, we did. Okay, so there's Claude MD in there. Okay, so that one's off it goes. Let's see how this other agent is doing. Okay. What have we got? All right, it's done the work. It's done the reading. We got our half-arc braid. You know what? Can you update the claude.md file to change the project name to HARific with capital HAR, please? It's not called braid anymore. Let's see whilst it's changing things, let's just keep reviewing what it came up with. We've got our CLI commands, root view serve version 2e. Okay, yeah. See, what we need is version, and that's it. Version, that's it. We need nothing else. I don't know why I put those in there. I don't know why I put those commands in there, but we just don't need them. 2e package. Yeah, we just looked at that not too long ago. Reviewed all that stuff. It's pretty basic. Half of it's not used yet, particularly the stars. And then we've got utilities, our HARgen, which we just use to generate a sample HAR file so we can read it in and test it. Git shows deleted files. Okay, I don't care about that. Yes, I do want you to edit Claude MD and see how our other terminal was getting on. All right. Great. We've got our context refreshed. Okay, all right. So today I want to start thinking about how we can build a hyper-efficient search engine that is going to be able to look through request bodies, all the metadata, as quickly as we possibly can, using both a combination of either just plain text search or regex search. And some of the things I want to take into consideration here is speed, right? And it's paramount that this runs as quickly as possible. So the design that I would like to use, unless you've got a better idea on this, is we build a sync pool and a queue, and we have workers. So workers would effectively pick off an entry from the queue. It'll go and run its search asynchronously in a Go routine, and then it'll stream its results back over a channel if it found anything. We would able to then keep the memory size really low because we have a reusable pool of memory. What would we call them? Just byte arrays or pick a data structure for me. I don't even think about that. Let's pull that back. Oh no, I've got too much in there. There it is. I wanted to pick a data structure for me, actually. I'm just reading what I've got here. Yeah. So we create a pool of memory, a pool of workers. They all run as quickly as they can without sucking up huge amounts of memory. The only memory that we should be using is for actually returning the results that they found. So anything that does create a match, we're going to have to load that request or that response into memory and return that as part of the search. There's no way around it, because if there's 10 results, then we need to see those bodies. We're going to have to pull those out. Actually, no, let's think about this. We don't need to pull the bodies out. We just need to pull the indices out. That's it. Let's delete that because I'm doing this rubber. I love this real-time rubber ducking. We don't need to load up the memory. We don't. No. Yeah. No. I'm wrong. What should be returned is an array of indices. Those indices are the results that contain what we were looking for. So then we can then just render that out in the table and say, this is what you're looking for. So when you click on them, you're still just loading one result at a time. You're not loading all that data into memory. We're only returning the indices of matches. That's a much better idea. That's a much more memory efficient way to do it. Much more efficient. So click on. It's not click. It's when you load them. Select. Pick them. You're still just loading one result at a time. Great. One result at a time into memory. One huge payload. There we go. That's more better. That's better. What I'd like to do is I'd like you to plan out an architecture that uses a sync pool with a very simple queue and some workers and some a pool of memory that allow us to perform this. Give me your most efficient design, and we can then look through that and iterate on it before we start actually going ahead and building it. I want to think about the interfaces that we expose and the mechanisms we provide for getting the data back to the consumers efficiently. Don't build anything, just plan. Design the architecture, design the flow of data, and perform a sanity check on the data structures we should be using for a pool and a worker pool and a simple queue. Let's see, a pool and a worker pool for a worker pool and a simple queue. But before we get into that, Claude, what follow-up questions do you have for me? All right. Whilst that one is thinking up some goodies, let's go back to our other terminal. Cobra CLI is saying I've updated it. Great. Okay, Claude. So the first thing I'd like you to do is what I want is to remove all of the commands that we've currently got, which is like view and serve, but we don't need them. View and serve should happen automatically. There's no need for them to exist. They should be triggered from the root command. The only additional command that we need to add is version, which we already have. So keep version as is. Let's collapse the view and the serve into just the root. We haven't built the serve functionality yet anyway. Does that make sense? And do you have any follow-up questions? No, not final questions. I'm trigger happy today. I mean, follow-up questions. There we go. All right. While that is chugging away, go back over to our search and see what questions are. Great questions. Before I design the architecture, I need to clarify a few requirements. What should be searchable in the HAR entries? Request bodies, response bodies, headers, metadata fields. I want to make it configurable. I want to make it configurable. I want the ability to default to headers, metadata fields, and request bodies. And then we should add a switch to allow a response body search as well. But initially, we should just look through metadata headers and request bodies to keep things fast. And then when you want to do a deep search, you'll add a Boolean and you'll get the response body search as well. All right, great. Next. Oh, hang on a minute. I need to go off stream for a second because I've got a meeting. I'll be right back. So I'll be back in about 5 minutes. Back in about 5 minutes. Unfortunately I forgot that I have this. Be right back. All right, I'm back. I am back. I am back because our meeting is over, and here we go. There was a question. I'm not sure if you're still on the stream. Apologize. I was in a meeting. Back now, but on Twitch, we had. I don't know, my chat window has moved all over the place again. Let me move that out of the way. Dearie me, this is not easy on a laptop. I tell you that. I tell you that. It is not easy on a laptop. Windows get all over the place. Move that damn thing out of the way. Alright. That should be a bit better now. There we go. It's kind of better. Kinda. No, not really. Not really. Not really better, is it? Not really. Not really. Make it a bit easier to see. I'm just messing about with this chat thing here. There we go. That should be better. All right. Let's just leave it at that and carry on. There was a chat message in there. Yeah, again, sorry for gone. From WRNK. It looks like a little smiley face. I'm not sure what that is, but anyway, this is a tool. It's a business tool we're building it live. We need it for internal use. I'm mucking about my microphone here. Sorry if it's clicking. It's an internal tool for passing HAR files, HTTP archive files. It's something we release open source, so everyone can use it. It's very specific in its use case. It's going to be useful to about 1% of the population that need to look in HAR files at some point. But when you need that tool, when you need the tool will be here. It'll be ready. It'll be working. Okay, we were in the middle before the meeting. This is my last meeting of the day. I've got one this afternoon, but this is the last one. We've got a big, long, straight run now. It's great. Can get some code done. Where we were was defining and designing the search architecture for how we wanted to be able to look through the indices, dispatch different jobs, have workers pass them, send the results back over a channel, and then we can aggregate them and then re-render them. So what I'm doing right now is answering some questions from Claude that we put together when we were working on it. So I've got the stream indices as found, send each matching index immediately. Yes. Batch results periodically. No. Complete scan first. No. Let's stream. Because we've got the data. We're just going to stream. Yeah, we'll stream it. We'll stream it in. As the data is available, we'll render it. Should the search support both plain text and regex, or just one? Both. Detect if a pattern is regex, otherwise use plain text search. Both. User specifies whether to use plain text or regex mode. I'm going to say both. Both. What additional context should be returned with each matching index? Just the index? The field that matched? Match snippet? Ooh, the match position. What do we need? Let's do, I'm going to type something. We're going to do the index and the field that matched. Nothing else. Nothing else. Because we'll be able to render that data. Yeah. Let's leave it for now. This will do for now. Oh, when I pressed return, the tick went. Ah. I hit submit. See that? I hit submit. You have not answered all the questions. Search scope. It did. Whoa, this is a bug. Next. It hasn't picked up the search scope. What? I think we've got a bug here. Because I've got the search scope. I've got this. Okay. Now I picked it up. No, there is a little bug there, but not really. Little bug. It's a little bug. A little bug in Claude. Anthropic, did you see that? Did you see that? Did you see that? All right. Let's submit. Submit your answers. Go. Build. Build. Let's see what it comes up with. Whilst our search engine is being designed, let's go back to our other terminal, our other agent, and see what our agent was doing. And the other agent was saying, yes, that makes sense. And what we asked the other agent was, we're trying to remove commands because we've got view and we've got serve. View and serve, and we don't need them. I want just them to run off the root. I think the version should be there. So the questions that we need to answer is, why is sometimes question when we've got plan mode? Maybe because it only happens to be a plan mode in. Plan mode, the questions come. If you don't have plan mode, maybe that's why. Anyway, a few clarifying questions before I proceed. How should the root command determine which mode to run? Option A, a flag like no, there is no mode. Okay. Question 1, there is no mode anymore. When we build the serve capability, it'll just boot when you're viewing the TUI. There'll be no mode selection. Question 2, half file argument. Should the half file path be a required positional argument for the root command? Yes. Yes, absolutely. Hang on. Question 2, yes, absolutely required. It's a positional argument, 100%. Question 3, the port flag should remain, and there is no mode. There's no serve mode. So if the flag is added, then set the port. If not, just default it. Question 4, default behavior. Someone just runs Harific my file with no flag. Yes. So question 4, if somebody runs just Harific my file with no flags, it should launch the TUI, and when we've set up the server, it should do that too. It should run all of it. There is no mode anymore. Do you have any more follow-up questions for me? Let's see what it does. While that is cracking, let's go back to the OG. See what we got. See what we got. Let's take a look at our design. Our design. I'm just going to clear away. Got no chat going on right now, which is just fine. Still looking. Oh, we've got quite a bit to look through here. Well, quite a bit to look through, ladies and gentlemen. Here we go. This is what we're looking about. This is what we're talking about. The HAR searcher. Oh my goodness. Excellent. Now design the hyper-efficient search architecture. Let me create a comprehensive plan. Great. Here's the plan. Core design. Let me zoom in here. Now that is very frustrating. The fact that I can view the plan in VI. That'll be a better idea next time. Run in Vim. All right. Memory efficiency via a sync pool for reusable buffers. Yes. The speed via the worker pool and concurrent search. Yes. Streaming results. Yes. Indices are sent immediately as we found them. Stream them over a channel. Lazy loading, which is perfect. We only fetch full entries when we're full entries. Fetch full entries. Get it out, mate. Get it out. We only fetch full entries when we need them. So we're only when we're pulling them out from, you know, you want to select the indice and the TUI, or we've got an API call we found, whatever. We'll figure that out later. But we only load when we need it. Lazy loading and early termination. Metadata search first, skip full entries. If we find it, yeah. If we find, yeah. Okay, yeah. I'm up with that. On the architecture components, what have we got? Searcher interface and types. The searcher interface, search, searcher, and search. It's about as simple as you can get, really. The reason why I don't have any, why I'm not floating normally, usually look a nice kind of key, ultra key behind me. I don't have that because I'm in an office. I could try and use the whiteboard, but if I use white, well, my hat's going to go all funny. So you normally need like a bright green or something that you don't normally wear, which is a problem because I've got green in my tattoo anyway. You don't care. We're looking at our APIs. Searcher interface. Search. First argument is the context, which it should always be in these types of things. The pattern and the options. And that's going to give us back a channel which takes a type search result and an error. And then we get stats, which is search stats. Should probably return pointers. Should probably, oh, unless it's turning an interface. Unless that search stats is an interface. No, it's a struct. Okay. Let's fix that. So I didn't bring my big red book of mistakes. Don't have anything to write on. Search options. Mode. Case sensitive. Search metadata. Search headers. I don't need this. I don't think we need that. Actually, that. Okay, before we get too into it, no, I want to keep planning. I'm just looking through some of these interfaces and structs, and I've noticed that you've added a couple of options which I don't think we need. Case sensitivity, don't need it for now. The searching, the metadata, the headers, and the request body, they should always be default, right? And I don't think we need to turn these off. Otherwise, there's no point to the search. The response body needs to be turned on because it is going potentially a big additional load on the system. But we could be pretty sure that the request bodies and everything else are going to be pretty light. So these should all be just default. You can't turn these off. I don't know why you'd want to turn these off. I don't know what the value is if you turn them off. So does that make sense? All right, let's leave that in there and let's get back up to keep looking, see what else we can find. Well, there's a lot in here. You know what? I've got this magic spinner. Whee! There we go. Turn off my mouse and it will just keep scrolling like a flywheel. Okay, we looked at our search options. We've looked at the search results, the index to fill the error. That's fine. The search stats, entries found, matches found, bytes searched. That's interesting. Okay, duration, obviously. Byte searched. I've seen that before. Well, I've seen that before. But the HAR searcher is our main container of all the logic. We've got our existing motor streamer, which is what we need. Our reusable 64 KB byte slices coming out of a buffer pool. Thread save counters. So let's see what's come up with. Streamer sync pool interface. We're going to create a 64 KB buffer. I'm going to use that as reading basically as a pool of byte slices we're going to use as memory buffer, so we don't have to keep allocating over and over again. And then we've got our stats. All right, let's take a look at this architecture. Let's see what we've got. The consumer, the TUI, will then result channel. So result. Worker 1, worker 2, worker 3, worker 4. Q channel. All right, so we've got a buffer pool. This is where the memory is coming from. We've got our workers. We've got a work queue. I think we've skipped over a little bit on the workers and the worker design and the worker queue, worker count times 2. Or maybe we don't need to worry about that. We're going to define n number of workers. It's the memory pool that we need to worry about. But the thing is, what about chunking it up in groups, blobs? Like if you've got 50,000. Okay. Another thing that I'm thinking about is being able to define how much work a worker does. And is it looking at 1 entry, 2 entries, 10 entries? I think we need to be able to configure that so we can dial up, how much work each worker is actually doing. Because if we've got 50,000 entries, that's 50,000 workers. What if we only want 10 workers? We're going to have to get them to do a lot more work. So we need to think about the design there as well. And then perhaps think about a pool of workers, right? We've got a pool for memory, but do we also need a pool for workers? All right, okay. Got that context in there. So we've got our producer. Our producer is gonna run through. This is where we're gonna figure out how much we're gonna chunk it up. So the producer is really the key here to decide how much to load into the queue. These workers are gonna pull off the queue, do the thing, and send back to the result. Their result on the result channel. Now, TUI with them there to stream those results off that result channel. So the question is the producer. How intelligent is the producer? So let's go down here. It comes down to being able to configure the producer and how it's going to construct adding things to the queue and what the queue is actually looking like. And so I want to go into more depth on that and making that clean and robust. Let's keep going. All right, the search flow implementation. Compile the search pattern, regex if needed, once, not per entry. Yes. Yes, because that would be crazy if we did that. Recompiling that regex every single time would slow this down to a crawl. So we create a work queue and a result channel. Yes. Spawn n worker go routines. Spawn n producer go routines to feed the work queue. Phase 2, our producer. Signal workers went. So, okay, so the producer is basically taking an integer, total entries. Oh, it's all. Oh, okay, I think it's already got that. So it defines how many entries to swallow up. So it's going to iterate through it. And then work. Okay, so that's not very. This is not very sophisticated. That doesn't need to be though. Yeah, this is what that question is going to be about, is configuring the producer. We need to be able to put more brains into this because that's not very useful at scale. Workers, this is kind of the same thing. What we do is we'll get a slice, byte slice for memory, critical path. This is the search element, whatever that logic is going to be in there for doing the searching, and deciding on the options, the search of the context, the index to use. Let's take a look at that in a minute. Turn the buffer immediately and stream the results. As soon as we've used the memory, we return it back to the buffer pool. And then if we find anything, we return it back. And then we use an atomic add in 64 so we don't have to worry about race conditions on changing these numbers. We could use a mutex, but atomic is, I think it's going to do the job just fine without need for locking. Here's that main beef. Here's the main, the meat of the sandwich, if you will. Metadata search, instant lookup. Okay, return. So return early on everything. We find what we're looking for, return it. Step 2, exit only, go on there. Step 3, load full entry IO operation. Step 3 and step 5 are concerning for me. Actually, there's a line here, isn't it? Okay, so I think the only real concern that I've got is that search entry is using memory effectively. I'm not seeing how it's using the buff. We've got the buff coming in, but I don't see how we're using that buff. It's not being used at all from what I can see. So that's no good. It's just like it's, yeah, we got the design, but we haven't actually wired it up. All right. When I was taking a look at, oh, that was already in there. Search entry, I noticed that we're pulling out the buff slice, which is great, but we're not actually using it. Like there's no value to it. We've created it from a pool, we're adding it in, but nothing happens with it. We need to be using memory when we're reading in that data from a pool and not just requesting it from the heap, because the heap will just grow and grow and grow and grow and grow. So that needs to be part of the design. All right. Let's go back up and keep going. Data structure sanity check. The work queue, the chan in it. While the indices are small. The channel provides a built-in locking concurrency. Yes. No, we don't need a ring buffer. Don't need a ring buffer. 2x work account balances throughput and memory. Buffer size 2 times the work account. Buffer pool. Yeah, but you haven't done anything with it. All right. What follow-up questions do you have for me? All right, let's see what it comes back with. All right. Let's go back to our other agent, and let's see what we got. All right. No, I'm clear. Let me confirm my understanding. Here's the new CLI structure. HARific, HAR file. HARific, HAR file. Port. Yes. HARific version. No separate modes. Yes. Yes, Claude. You got it, my friend. Let's go. Great. Claude is go, going. Going. Let's go back and see how we're doing over there. Oh, we got more questions. Excellent feedback. You're absolutely right on all points. We're absolutely right, everyone. Absolutely right, people. So let's ask some clarifying questions before I refine the design. All right. Number one, how should work be divided among the workers processing entries? Number one, the fixed batch size. Each work item, fixed N entries, 1,000 entries per batch. Simple, but it may leave workers idle at the end. Yeah, I don't think the batch sizing is right. Dynamic partitioning. Divide the total number of entries by worker count, i.e. 50,000 entries divided by 10 equals 5,000 each. Balanced, but less flexible. Configurable chunk size. User specifies chunk size. The producer creates batches of that size. Workers pull batches from a queue as available. Dynamic work stealing. Start with petitions that allow idle workers to steal work from busy workers' queues. Questions. So what do we want on the logic behind figuring out how to, our batch size, our pooling size, which technique do we want to go with? And I am leaning on a mix of dynamic and configuring. Let's do this. Let's go in there. Let's go in. Let me do something slightly different. I'm actually leaning on a combination of dynamic, but with actually no. Let's change it. Configurable, but with a fallback to dynamic partitioning if the configuration is not provided. Configurable chunk size. Go back. Configurable chunk size. Sorry, chunk size. Yeah, okay. Yeah. That's what we want. All right, buffer usage. Entry reading layer. Modify the entry reader to accept a pre-allocated buffer size. This is how we deal with our memory. The most efficient requires changing the reader interface. That's no big deal. We haven't committed anything yet. JSON unmarshalling. Use buffer for the raw JSON binds before unmarshalling entry struct. Medium efficiency. String searching. No. All of the above. All of the above. Use pool buffers at multiple stages, reading, parsing, and searching. Yeah, I think we need to go with number one. We're going to need to modify the signature to accept a pre-allocated buffer for file reads. Most efficient, but requires changing reader interface. Let's say one, but with conditions. I want to go with option one, the entry reading layer. We modify the reader interface. So we bring in that buffer, but I also don't want to just add another argument to the interface or to the signature of the interface. What I'd like to do is change the signature completely to be message based, so we can then expand the configuration as much as we want later on without changing the signature of that. When I say signature, change the number of arguments of that design. Just give it that last sentence because it sounds a little bit rambly. All right, that's cool. Worker model, fixed end-go routines. Spawn end-go routines at the start. They'll run until the queue is empty. Simple, predictable, bounded concurrency. Sync pool for workers. Pool of worker objects that can be reused across multiple search operations. More complex, mainly useful if running many searches. Do we front load and complex? So the question here is how complex do we want to go up front? Do we want to implement a workable? It's one of the questions I asked at the beginning. Like, do we want to use this? Should we be using this? But we've got end go routines, and they're basically just going to keep running against the queue in chunks, in batches until it's done, and then it's done. Or do we build a pool? Let's go with fixed for right now, just to keep it simple. I don't want to overcomplicate it. And when a worker processes a batch of entries, how should it handle finding multiple matches? It's an interesting one, isn't it? Stream each match immediately to result channel. Fasted feedback. Yeah, but batch results per worker. The worker collects all matches in his batch. I'm going to do that. I think for now, let's batch it up, batch it up. All right, we've tuned the design a bit more. Let's see what it comes up with. In the meantime, let's go back to our other agent who is talking about CLI architecture. Yes, don't need to worry about that. Okay, up it goes. It's going. Go back to other view. There's nothing going on there. That's thinking. Let's come back to it. Yes. Keep going, Claude. Right, that's going. Let's see where we are. Where's Claude going? I think we actually might be in a good place here. We've got a pretty good design for our search engine. I'm going to get it once that's going. We're going to have to build some tests. Then we'll focus on UI a little bit more. Ugh. Well, Claude is still going over there. Let's have a look over here. Ready to implement. Let's go back and see what it's got. Okay, this is our modified, tuned up plan. Let's make sure the plan is good. Plan is good. Refined, hyper-efficient HAR search engine architecture. We have our core design principles. This is based on what we already discussed. Deep flag search, the mode, plain text or regex. So in the TUI, you'll hit a switch, it'll turn that on or off. We'll do a deep search flag for searching the body or not. That'll be another tick. And then the chunk size is the entries per work item. 0 is auto partition. Very nice. Very nice indeed. Always searches. You can't configure this. It's going to search the metadata, the headers, and the request body. I think that's fair. Server IP, MIME type status. Headers, bodies. Yes. URL method. Yep. Okay. Message-based entry reader interface. So in our mode, we're going to modify our read request to include our buffer. This is important if we want to keep our memory clean. And we need to do some benchmarks, add some benchmarks to this to make sure that we're actually going to keep that, honor that. This is what we need to change. Our entry reader. Context. Okay, great. So we pass in a context, and we use read request and return read response. Can we make those interfaces? I want to make those interfaces just for this, because to make this. All right, so. I was looking through some of the configuration, and I'd like to move some of these structs to interfaces so we can truly change the implementation later on. The design is fine. I just don't want to use raw structs. I'd rather have those interfaces with getters on them or setters if we need them. Okay. Let's get back up to our design. The work distribution with our batching, work batch, struct, start index, inclusive start, exclusive end, go range. I don't think we need to worry about those comments, but whatever. Create work batches, total entries, and the search options. Chunk size is 0. It's going to use the auto partition. Chunk size. So the chunk size automatically gets pulled out by the number of entries in the work account -1 divided by the work account. If there's nothing in there or it's too small, we'll do it to 100. That means 100 entries per worker. Too big. We'll figure that out. There's some basic numbers on the distribution for workers on chunk based on. Anyway, that looks okay. It looks okay for now, but we're not really going to find out what the sweet spot is until we do some profiling and test the speed and test pooled sizes with some massive data. We'll come back to it. The consumer and the TUI. Okay, what this is going to do is it's going to receive a slice of search results from each worker. Worker N, 1, 2, 3, and number. What it's doing is it's pulling the buffer. It's pulling the memory buffer. It's doing a search using that memory buffer to read the string in and then do its whatever it needs to do. Shouldn't be any decoding going on in there. And then it will turn that memory back to the pool. We have a work queue. The producer is going to produce these batches of N number, whatever it might be. Here's our work implementation with batching. What we'll do is going to keep running until the channel's closed or done. Whilst we keep iterating in our for loop. It's been closed, we're done. We get something from the buffer pool for memory. We pre-allocate. Why don't we pick 16? 16 search results. Just curious where you came up with that number from, Claude. Where'd you come up with that number from, Claude? Where'd you get that number from, Claude? I'm just curious why you picked 16 here. Where'd you get that number from? Why do we need 16 in there? 16 in there. Shh, wait. Too far up. Where are we? I've gone too far. No. Almost there. Here they are. Looking at pre-allocate here. Process each entry in this batch. Start index, end index. Memory back. Check for cancellation every n entries. Magic numbers, Claude. I'm also curious about where you're getting this 100 number from. Where are these magic numbers coming from? Search the entry using the pool buffer. Yeah. And then we're using atomic +1 on those entries. Add in. Yeah, it's going to add 1 to the pool. Put the memory back. Where is it? Can we pull it out? Yeah, we put it there. Okay. All right, if it's been cancelled, we put it back. Then we put it back anyway. Why don't we put it back twice? Turn. No, it won't. It will just return. Okay, great. Sends back results. Even if empty for process tracking. Send it back on the channel. And 1. Okay, no, that's right. That's right. That's right. That's right. Moving on. Search engine with buffer usage. No IO. Instant. Always enabled. Read request. Read from the buffer. Yeah. Yeah. Always enabled. Always enabled. Optional. If that's set on the configuration. Yeah. Reader. OS file index. File 6. This is it. This is what I'm looking for. Gray reader. IO reader. Read into the buffer. Yeah. What's this? What is that? Not recommended for search. The fudge is the point then, Claude. Decode, entry, okay. Just make sure that JSON reader is coming from our buffer. Okay. Okay, so I'm not going to get a bit of pressure on the garbage collection here. Reading the metadata, file offset, yeah. Complete search flow. Search, here's our validate, compile the pattern, yes. Total entry, rate the batches, create the channels, start the timer, so we can, yeah, spawn the workers. Go, fill up the queue, and then suck all the queue out. Perfect. Let me use it for the chunk side. This is all BS. I'm not buying that at all. I'm not buying it. But we'll see. We'll see. The JSON decoder will chew up. Yeah, I don't know. We'll find out. We'll find out. Sequential. Okay. So, this is what I wanted. This is where I want this engine to be performant, because it's saying, based on 50,000 entries with 10 workers, if we were to do this sequential, I run through this row at a time, it took about 14 seconds to do 50,000 entries, which is far too slow. We do parallel with 10 workers, which is what we should be doing. And we can increase that worker pool, depending. We'll do some benchmarking on it to 1.5 seconds. Now, if we add the body search in and turn that on, let's say it's 100 KB per body, we're looking at 10 seconds to search through that 50,000. And that could be like 50,000, we're probably looking at, I don't know, it could be varied, but with 50 to 100,000, 11 seconds. That's why we need to make this configurable. The body needs to be configurable, because it will slow things down I take 1.5 seconds to 11.5 seconds. Let's take a look at our key design decisions. We've moved on to the options. We have a working batching. No. All right. Let's. Okay. Do you have any follow-up questions for me? Let's. I posted that in. Let's see how it gets on for a minute. We are going to go back to our other UI. Terminal 1. Terminal 1. Terminal 2. Terminal 1, Terminal 2 says done. Says it's done. Is it done? You know what? I don't know. I have to add another terminal. I'm adding another terminal. We're going to test. Terminal 1, Terminal 2, and Terminal 3. And then I've assigned a new button for it. Bear with me. I'm doing this in real time. I'm doing this in real time. So I'm going to add screen capture. And in my screen capture, I'm going to configure it via window. And I'm going to configure it to look at ghosty. And then configure it to load up this new terminal. And what we're going to do in this new terminal is we're actually going to be running HARific. Running it in real time. Okay, I've got that sorted out. I've got a terminal up here. I'm going to bring it over so you can see it. Still working on it very briefly. Give me a second. Terminal 3. All right. Let's do one more thing and add a button for it to my stream deck so I can hit a button and then you can jump over there. Change that terminal 3. All right, great. Terminal 1, Terminal 2, Terminal 3. Perfect. Okay. Thank you for bearing with me. All right, so let's do this. We're going to do go build HARific.go. And then we're going to run HARific. And nothing happens because we have no argument. Now, if we do test 500 MB, what we should see now is it popping up, ready to go. Pop. Beautiful. 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 All right. Now, next challenge for this agent over here. Oh, it's not this one actually, is it? It's going to be not that one. It's going to be this one. Here we go. Okay, Claude, great job. Working as I wanted. Now I want to move on to the next thing. If you take a look at the TUI code, and when we bring up the split view, one of the things I'm noticing is certain records, the left split view that has no request body is shorter than the right request split view that does have a body. And then, I can scroll up and down in that. One thing I'm going to want to be able to do is have those two split views to be the same size. They should always match. One shouldn't be larger than the other one. But the second thing is I want to be able to hit tab on when I've got the split view up, and tab is going to select, toggle the window, the left or the right, the request or the response. And then that's going to activate that window, make it active and focused, so I can then scroll up and down depending on whether it's the request or the response. Because right now, it just scrolls the response. It doesn't scroll the request. So I need to be able to select them using the tab. Does that make sense? And do you have any follow-up questions for me? That's a nice big one. All right. Let's see what Claude comes up with. Any follow-up questions. In the meantime, while it's cracking on, let's go back to our other terminal and see what questions we have. Great, more questions. For the batch results and the pre-allocation size, what should we use? No pre-allocation. Start with a nil slice and let it grow naturally. Simpler, but it may cause more allocations. Configurable constant. Define a constant like expected matches per batch equals 32. Ugh. Smart, small. So deciding how we want to pre-allocate based on chunk size, configurable, ignore it together, or start small and grow it. So start with a small capacity, either 40, go to pen, we'll double it as needed. Do we batch? Do we go for a balanced point of view? Do we, based on chunk size, which is going to change it based on our configuration, it's going to have a downstream knock-on effect. Do we make it a constant so it's always going to be the same thing, or do we just start with nil and then it grow naturally? But that will obviously, create more allocations and slow things down. Let's go with 4 for now. Let's do balanced. For the context cancellation check frequency every n entries, should we remove it entirely? Only check the context when pulling from the work queue. Simpler, workers finish their batch even if casual. Yeah. Check on every entry. So this is basically determining whether or not we should give up early. Make it configurable. We use a sensible constant. You know what? I'm just going to remove it. Remove it entirely. I don't think we need it in there. Unless we start to see some kind of over-processing. Like, we find it and then we've got thousands of workers still operating. So for the read fallback when no buffer is provided, should we keep it? Remove the fallback completely. Require the buffer in read request. Search always provides one. Fail fast if it's missing. Keep the fallback for compatibility. Allow the nil buffer for non-search use cases. Interesting. Non-search use cases. All right, keep the fallback. Keep it, because it means it's adaptable at that point. All right. So how should we define the read request and read response interfaces? Full getters and setters, get offset, set offset, get buffer, set buffer. Maximum flexibility. You want to make it full read and write, read only, build a pattern, or hybrid. Let's use the builder. Let's use the builder. All right. Let's go back to the other terminal. See how we're doing. Answer the questions. Equal viewport sizes. We're going to tab to toggle the focus, and 3, the focus viewport scrolling. A few follow-up questions. Visual focus indicator. Should there be a visual? Yes. 1. Yes, please use the primary blue to highlight the border of the focused panel. 1. 2. Default focus. When you first press enter to open split view, which viewport should be focused by default? The request left or the response left? Request. It's how we read and think. In English, anyway. 3. Table scrolling. When the split view is open, should the table still be scrollable, or should arrow keys only control? No. 3. When the split view is open, it assumes focus. The table in the background can only be accessed by hitting escape, so you get focus back to the table and close the split view. Great. Let's go back to our other terminal, see if we're ready to build yet. Are we ready to build? I think we're ready to build. I think we're ready to build. We've been designing now on this for a couple of hours. Good couple of hours, and I'm pretty happy with our search design. It's clean. We're using all the right patterns in there. Search engine research with a builder pattern. I just want to take a look at the modifications here, just to make sure it's clear in my head. All right, here's the updated pan. Final hyper-efficient HAR search engine architecture. Builder pattern using read and request. Read and request and response reading. Get out, mate. We're going to remove the context check inside the batch loop. We don't need it. We've got small initial capacity for batch results. A bit worried about that. We'll see. Keep the buffer fallback, yes, so we can use it outside of this, and simplified search options. No case sensitivity, meta, all that kind of stuff is always good. So here's our interfaces, which is good. Gets, and then our request builder with offset, and it returns the builder, and then we do another one, and we builder. Lovely. Yeah. Okay. All right. Okay, this is looking good. Now it feels right. Now it feels right. So I'm just sending a Slack message. It's the lunch order for today, and I had a look at it earlier, and I won't be ordering lunch today. I'll probably just go and get a sandwich or something. It's Indian food, which is delicious. Love Indian food, it's my favorite. But I can't eat it for lunch. It's too heavy. I'll fall asleep. I can't hack if I'm falling asleep, can I? So yeah, I'll have something lighter, I think, like a pizza or a burger. Joking. Back to our code review. Benefits. Builder pattern's good. We've got interfaces in there. The worker. Search results. Searcher. All right. You know what I'm going to do? Is I'm going to have the LLM write this to a plan file. I'm going to change the model to Opus and have it take a look at it, and then decide if there's anything we've missed, or anything that we need to think about, or any other additional questions, and then we'll build. Can you write this plan out to a file called plan.md for me? Just responding to a message on Slack. Sorry if I go quiet and I do that. I apologize. All right, let's wait for this message. This message, because we're going to change the model. Once we got our message, we change the model over to Opus. Have a look, and then we'll get building back with Sonnet. I've chewed up quite a lot of my Opus work already. My Opus allotment for this week. I was doing some work yesterday outside of this hackathon, and I was running Opus on it. It was a design thing. Astro Diagnostics thing is a really complicated diagnostics on a highly recursive renderer that I built, and I blew through a lot of credits. Whilst I'm waiting for that, let's take a look at our other. See what's going on. Well, we've got one agent now operating away. Let's leave that. Come back to our other this agent here. Waiting for our plan. Waiting for our plan. We're going to get Opus. Take a look at it. And then I'm going to take a break for 5 minutes. About 4 hours left. We have about 4 hours left. Maybe longer. Depends on how juicy I'm feeling by the end of our session. But we're making good progress right now. A large part of what I wanted to get done this morning was figure out the search engine and get the UI tuned up and start rolling it. Okay, so yes, please write my plan. Then we're going to get Opus to have a look at it. Where are you, mate? Great. Ready to review and iterate on the plan, or should we proceed with implementation? Just wait 1 second, my friend. Yeah, I know you're running Claude. Let's do this model. Opus. Can you review the plan in detail and look for any gaps or holes or mistakes or confusion that we may have introduced? Does it make sense? Is it clear? Is it crisp? It's these types of exercises that I often like opening up to an LLM. Because when we're designing, I need to be very specific about what we want and what I want. And I want it to give me options on the variations of that. There you go. Look, there's that bloody approaching Opus weekly limit. And that will appear on and off now for a little bit until I use it all up. But I often like seeing what the LLM comes up with when I feed all of it. And I say, look at all of this. Look at it. What do you think? Is it good? Is it bad? Go list. Oh. I mean, you don't need to. I don't know why you're doing that. I don't know why you're doing that, mate. Don't know what you're looking for. It's using a bunch of tools. Check in on Claude 1. Claude 1 is done. Whilst we're waiting for the analysis to happen, we can flip back over and see what we got. Perfect. All the changes have been implemented perfectly. Here's what I've done. Focus and state tracking. We've added a focus now, so we know which panel is active. The tab, equal viewport heights, the split height calculation is correct. We've added a tab key and a visual focus indicator. Now what we're doing is we'll set the lip gloss to put the border around those viewports. It shows which panel is active. We've got focus viewport scrolling. This should allow us to scroll up and down on those bodies. Updated. I didn't ask for that. Mate. Claude. But actually it is pretty helpful. It's added request or response to show you which is actually active. All right, well, let's go ahead and try it out. Build you up. Let's run, yeah. Scroll and hit. Well. We do have progress. I can see in the footer that request is selected, and I can see that hitting tab is actually changing the active, and I can scroll up and down in the active, and there's nothing to scroll in the request. We still haven't got that height sorted out though. So an empty body, but it is functional on the rest of it. We need to get rid of that. We need to get rid of this. We need to get rid of this. What is this? All right. Let's change. Let's give it some feedback. Let's hey, here's some feedback, me old mucker. Because oh no, that's the wrong one. Here's some feedback. Okay, Claude. It looks like the tabbing is working, and it looks like the highlighting is working, but the footer seems to be a bit of a mess now. This is kind of what it looks towards the end. I can see we've added the request and response in brackets. That looks good, but that should be at the end. Okay, put that at the end and get rid of that URL. That is not useful. Get rid of the URL of the entry that we're currently looking at, please. Please. All right. What else was in there? I want to take a screenshot, actually. I'm going to take a screenshot of something. I think other things I do enjoy about Claude, or even Claude Code, would be a better definition. Is, let's show this. This is what it looks like. No, you can't see what I'm doing here. Okay, I'm taking a screenshot of what it looks like this. And then let's find one with a body in there. These are all empty bodies. All these are requests. We'll find a post. No. There's one. Ah, now I've got two screenshots here where the path is not correct. Right, so I've got those in there. What I want to do is I'm going to come back to Claude, not that one, this one, and I am going to drag those screenshots into the terminal so we can actually see them. And it will paste it in. I won't paste the image, but it will paste it in. Control my computer properly. If I can control my computer properly. Here we go, 2 screenshots. Take a look at those. You can see the heights are not the same, and we still have work to do. All right, whilst that's going, we're going to flip over to our magic numbers, see what, and see, let's turn off Opus. All right, Opus did a review. Let's see. Critical issues found in the plan. After a detailed review, I've identified 40 issues ranging from blocking bugs to design inconsistencies. Here are the most critical ones that prevent the code from working. Blocking, okay, it does exist. All right. This is, all right, sorry, I've got the wrong Claude up here. Sorry, reading this. This is our search engine. Stupid go away with that nonsense. We're not welcome here with bots sending us follows kid. Right. Waitgroup.go does not exist. It does exist. It's part of 1.25. You're being dumb. see that the wait group go syntax does exist. It was added. You're out of date. Saying the type assertion panic in new searcher violates linear search for metadata. Okay, 3, 4, and 5. Major performance issues. File handle mutex bottlenecks. All workers share a single file handle with a global mutex lock. Completely serializes I/O. Okay, that's a problem. Yeah, exactly. This is that I was always thinking about. Hardly optimistic. Yep. Metadata search doesn't have a return. Yeah, I thought we. Yes. Yeah, I thought that as well. That's exactly what I was saying. Design inconsistencies. Context cancellation not responsive. No search options validation. Okay. All right. So questions and answers. Plan is ambitious and well structured. Answers to your questions. That is not your questions. First question is why 1 minimum 100 entries per. Question 1, why minimum 100 entries per batch? There is no minimum. That's just a made up number. It's not something that we should be actually adding to the plan. Question 2, the initial capacity for 8 results. Again, it's another magic number that was just made up by you. I didn't define that. You did. How to handle multiple concurrent searches. There won't be multiple concurrent searches. This is a single user tool. It's not a multi-tenant tool. It's not a multi-user tool. When you say partial field loading, what are you talking about? And please suggest recommended improvements to the metadata lookup that we need to fix. All right, let's let that cook and stew, and then we'll ask it to fix it, and then fix a plan. Let's fix the plan. Let's just fix the plan. We can get cracking. Yes. No. 1, 2, 3. 1.2.5, mate. You're absolutely right. Yeah. Oh, we're absolutely right. Absolutely right. Okay, while that's going, let's see what we've got going in UI land. Yes, allow. Oh, you haven't even read the. Wow. Okay, well, you're off you go, Claude. We'll go back to okay, we're ready. Yes. on number 4, absolutely we have to have a fold handle pull or some kind of pull. We should fix that mutex contention. That will absolutely slow us down. Please update the revised plan.md with all of these specific fixes. All right. Let's see where we're at with UI Claude. Fixing the viewport panel heights to be truly equal. You said that last time, my friend, but we still don't have truly equal panel sizes, do we? It's gonna have something to do with the content size. I know it. We haven't even got there yet. We need to get onto the rendering of the request and response in a bit. In fact, I think next let's tune up the table just a little bit. Let's just make it look a little jazzier because it's not very nice. I'm bringing some code. Bring some code from Vacuum that does path rendering. Got some nice path rendering code in there. It's URL rendering, that is. Whereas in this not gonna work because it's straight up HTTP, isn't it? The rendering out there. Parameters. Can't. Claude is cracking on over there, fixing those view heights. Let's see what our search engine is saying. Fixing the plan. Yes, edit the plan, and then we're ready to build. I'm gonna add some tests. Test, and test it with 500. Yes, I do need to make that change, Claude. That's as wide as I can make my screen, by the way. So I can't get the terminal full width because it's as big as my laptop window. Yes, I do want to make. Why do they keep adding this name? Oh, I see what we're doing. I see what we're doing here. How are we getting on over in UI land? How are we doing over there? Okay, it says you've removed it from the status bar and the panel should be equal heights. Let's take a look. Rebuild. Test you up. 100 megabytes. Oh, look at that. We are the same size. It's too small, but we'll make it bigger. We'll go and manually edit that in a minute. Nice. We're going to see what logic gets done. We'll just increase it. And then we can exit, escape, scroll, nothing in there. Every single one of these bodies is empty. I'm going to need to test some of Yeah, okay. Let's go and take a look at that in a minute. See if our HARgen is just creating. Look, it's just creating. It's creating everything. And this is working. This is great. But it's creating empty bodies. I think they're all empty. They're all empty. Okay. Well, that's actually looking pretty good. Let's go and see where we are with with our UI bot. Let's go back to the plan bot. Yes, edit the plan. And then we're going to build. Then we're going to build. Making progress with the UI, making progress with the search. Two-and-a-half-hour plan to get search. I'm pretty happy with that. I think it's good. This thing is going to be a bit glitchy. Might be a little bit over-engineered, to be honest. I think we've over-engineered it just a little bit, but that's okay because it needs to be performant. But it might be just a bit too much. There's too many moving parts. It means we're going to have to delete some of this stuff to actually probably test it. That chunk size is just making it up, aren't you? Making it up. Magic numbers. Magic numbers. Nothing worse than magic numbers. I always try and avoid them. It's really hard to do when you're doing graphics, though. It really is really hard to avoid magic numbers from graphics. Any kind of graphical like rendering or algorithm, but these numbers are fixed. They're fixed, and trying to make them all constants, it's just it gets messy. In this plan. Let's see. I'm gonna get it built in. Come on, Claude. Come on, mate. Come on, stop drip feeding. Stop drip feeding me. Let's go, bud. I might just switch it to just edit. Just edit. Come on. Let's go, Claude. Those early returns, find that metadata. Don't want to keep going. Oh yes, just edit the damn thing. Edit the damn thing. Come on. Direct lookup in the index, linear scan. Could be optimized with a map. Oh look, there's a map. File pull, metadata lookup, buffer size validation. Yes, these things are all important, but now we are getting into a little bit of over-engineering. If I'm being honest, it is a bit over-engineered now. We've got to stop adding to this plan, and we've got to start building. Come on, Claude. 10 minutes to update the plan file. 10 minutes. Come on. So strange it does things like this. Memory map file access for very large half. So picks up context and thoughts and ideas from just some random places sometimes. Plan is now production ready. Okay. Okay, Claude, let's do it. Please build clean, dry code that's pragmatic. All comments should be essential only and all lowercase. Do not put obvious comments in where we just don't need them. And please make sure that you run the performance-code-reviewer with every phase of build. For this first round, I want to implement at least 70% code coverage to validate the core engine is operating at requirement. And it's fine to use individual tests or table tests. I'm not entirely bothered. Do you have any follow-up questions for me? Should I follow the plan's implementation order? Phase 1, refactor first, and phase 2. Phase 1, phase 2. Build the search engine with new interfaces and integrate the reader changes at the end. I'd say implement together. Do it all together. File handle pool needs cleanup. How should file handles be closed? Add a close method, finalizer. Add a close method. If OS open fails in the file pool's new function, what should happen? Return the error. Oh, I don't care. Your choice. Let's go. All right. Claude is now rolling. Claude is going to be editing and changing and adding for a little while. And during that phase, I am going to take a 15-minute break. I will be back at 11 a.m. Pacific, and that is 2 p.m. Eastern. I'll see you in a bit. All right, back online. So, made a big old mess, and it says it's changing everything. While that is going on, I want to jump back to our UI agent, and the panels are perfectly aligned. But let's go look at some code. Let's look at some code. We're in the TUI. We are in the TUI, and I want to go back into our view. Let's go take a look. Max body display length. Max your display length. This is curious. Where are you being used? Look at that. What? Okay, so what I'm looking at here is truncation that's happening on the body. Actually, before we do that, I think we need to go back to our demo, because looking at the what I want to tackle. There's two. I'm trying to think out loud here. There's two things to tackle. The first is the next step, which is, do we want to build the next piece of functionality is within, which is when you do have the request of the response loaded and the body is significant and it needs to be truncated. We want to bring up a rendering, or do we want to fix the actual rendering of the panels, or do we want to sort out the layout of the panels? I'm not entirely sure what I want to do first. Yeah, format response. Right, it's fixing this entire thing to use lip gloss in a more effective way. It's just writing the strings out, it just looks out pretty boring. Or update the viewport content. Let's see which code is controlling the height of the panels. Render split panel width, panel height, m.height divided by 2 minus the table vertical padding. M height. Where are you coming from? M width. Where are you being set? Let's find the right values of m.width. T window size. m.height, message.height. Okay, well that's coming through on that. So we can not worry about that there. Come back here, the height divided by 2 minus the table vertical padding. What are you set to? 4. This is where those numbers are getting a bit funny. I am going to just copy this, disable that, and get rid of this vertical padding and see what's going on. What does that look like without that? Get rid of that table vertical padding, and what we'll do, render it out. So that padding is really messing out. It was the padding. Look at that stupid padding there, need that. Now we've got the body, which is truncated. Let's do the next thing. Let's put a border around the table. put it into a container and give it a nice pink border. And then we are going to color. No, sorry, this seems like someone's building something next door to me. I don't know what they're doing. Sorry, it's coming through on the microphone. Why is someone banging? Because that's what you do in an office, isn't it? Bang. That's why people don't come in to the office. You're just sitting there and it sounds like a construction zone. So I'm thinking about what I do next here. Do I want to focus on rendering these out, or do I want to render the table out a bit better? Or do I want to fix the header? Yeah, let's fix the header. There's some padding around this. Let's get rid of this padding and put a box around it. Nice pink box. And a pink box around that. Okay, let's do that. Pink box. Or should we put a white box around it? Oh, I don't know. We'll play around with this. Play around with it for a minute. Actually, let's see how our search engine's going. Oh, it's asking us a question. Yes, go doc. God. Right. I don't know what you're doing there, but you're obviously confused. Let's go back to our code. And let's go up. Here we go. Back of the code. Alright. So that table vertical padding. Where are you defined? Where are you defined? Here. It's 5 usages. Ugh. You're everywhere. Where are you? Where are you? Here. 2. 218. Initialize table. Minus table vertical padding. Let's just change this. 4. 3. What is that going to do? Off they go again. Bang, bang, bang. What the? Can you hear that? Alright. Oh, you see, the padding. We've lost our. We need to change. See, when I do the vertical padding, we're losing the footer. We lose that. All right, let's bring that back. All right, stop mucking about with that. Let's go and look at the header. Let's go look at the header. That's the header is the thing we want to fix them first. Where's the header? Split view, table view. Let's see if I can bring up a navigator. Where is the navigator? It's been a while since I used it. Where are you? Git. View. Window. Where are you? So I'm looking at my code here. Can't see the drop downs when I'm clicking drop downs at the moment, trying to bring up a view, a navigator view, but I can't remember what the icon is. What is it? Structure? That's it. That's the one I was looking for. Structure. Right. Just so I can navigate around this a little bit. Where is armor entry? Quick loading spinner, truncate body. Where's the title? Where are you? Rendell Tide. There you are. Why can't I see you in the structure? I'm just blind. Let's close all these down. Render structure. I don't see render structure. Freaking HARview model. That's got to be in here, isn't it? Down here. This is where it all is. There it is. There it is. That's what I was looking for. Why is my phone buzzing now? What is going on? Buzz, buzz, buzz. Buzz, buzz, buzz. Alright. Don't know what's going on there. Okay, so the target, we got a space. Why? Hold. True. Yes. Padding 0, 1. Let's put a border. No, no, no. Border. Can't remember how we do a border now. What is it? Let's take a look at it. Take a look at the code, the border. The B is a border. Border comes in there. It's a struct. Top, bottom, left, right. Hang on a minute. Let's do this. I can't remember what the syntax is, and I built it all in vacuum for doing borders and stuff like that. It's a specific way of doing it. I'm going to bring up Chrome so we can go look at it. Where are you? Vacuum. 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 Vacuum, vacuum, vacuum. Let's take a look at the code. Syntax highlighting, message renderer. Where are you? Where are you? Link details. Table data. You in here? Border. There it is. There it is. All right. That's what I was looking for. That's what I was looking for. Okay, so it is border style, and then we do normal border, border foreground. Ah, okay, that's it. So we don't have to supply the entire border configuration. We just do border style, and then we bring in lip gloss on the border, and then border foreground. Yes, foreground. Do foreground. Well, let's leave the color off and just see if it comes in. Just make sure we're using the builder correctly here. No. All right, that should run. Why are you not doing the full width? Yeah, okay, so look at that. It has put the whole thing in there, but it's now got around the header just the name file, and the number of entries and the loaded time is not. All right. What are we doing here? Title style. Entry count. Entry count. Entry count. Ah, you ass. Look at that. Faint. Entry count. Okay. Let's try this. What we're doing here is the entry count and the indexing time is created as a separate string. It's created outside of the title. We want to bold the title, which means putting the entire thing in a border. We're going to make, we need to make it 100% wide as well. I can't remember how to do that. Anyway, what was happening before was it was actually concatenating them together, and we need them to be the title and the count style to be together. That's probably going to mean that there's a space there. Let's put this. Let's put a pipe in. Let's put a pipe in. Put a pipe in. I realise I'm not sharing my code with you. I'm just showing the terminal. Sorry about that. Just looking at the rendering title. I'll come back and rerun it. See if it made a change. Yeah, but so what's happened here is we have a style, and we put the style with a bold, and it's got a border on there, but it's also, because it's encompassing, it's also made this bold, which we need to change, which means reorganizing this a little bit. And then the next step should be, why is this not 100%? So can't remember. There was like calculation done on number of columns in vacuum. Let's we'll do this next with the what do you think about this? See if we can get the width first. Okay, first of all, I'm thinking out loud here. Fix that header. I want to fix the bolding. I want to get it 100% wide, and then we are going to look at rendering this grid out, this table, and have the status and duration be always pushed to the right. So effectively the URL takes up 99% of the space available when available. We have to do some column calculation on that, and it's a bit tricky. Did it in vacuum, you do the same thing here. But let's fix that. Let's fix that. Leading title first. Start. Alright, so bold. Let's get rid of you, because we're going to add we're going to create a new style here. Title style. Enter the account. Where are you? Title style. Yeah. And then we'll do title text style. Bold. No padding. All true. Yeah. We'll do the color. Text style. Okay. All right. So then we do title text equals title text style and title. There. So now we have our title style and title text plus count style and render the entry count style faint. Okay, yeah, that should be it. That should fix it. Doesn't fix the width though. I'm gonna do the width. Oh god. And width. Let's try it. It should be good. It should be good. It should be good. And it was. It was good. Now the question is do I like that pipe? You know what? I'm going to bring up the AI again. We can tune out. We'll be pissing about with this for hours if we don't move on. But we are making... Oh, hang on a minute. Now we've got to pull that padding back up because we're adding all kinds of stuff at the top now. Why is there a space there after between the table? Let's get rid of the space. Let's get rid of the space. I'm not need to move the padding. Render title. Entry count goes underneath there. Render status bar. Alright, so let's find out where you're being pulled from. Render. Oh, look at that. Double line break. No wonder. That was it. That was it. Hang on, I just realized I'm looking at the code again. So, in the render table view, we've got a double line break there. And we've got a double line break when the split view is open as well. You can see the split view is like it will render the title, the view, the panel, the split panel, and the status bar. And then when we've got this state up here, we'll only render the title, the table, and the status bar. It doesn't render the split panel. So these are the two different states. Whether or not you've got the split panel open, it will render, you know, the table, or it will render the whole shebang. We'll need another mode that will pop up. That will show things in detail, but we'll get to that in a bit. So that let's get rid of this. Don't need you, do we? HARviewer. This is not HARviewer, is it? Is it, mate? Is it? It's HARific. Okay. Let's get this bad boy spin, shall we? My prediction is that the line here is gone because we delete that double new line. We'll have our title back at the top and our status bar will be back, and we will be moved. Well, that's interesting. Now the table's in the right distance. Looks like we have a race condition of some kind. Because look, if I load this up like this, bring in it's right. Quit and rerun it. It's wrong. But watch, if I resize it, it's right. Look at that. Ah, we have a bug. We have a bug because it's right size. This is correct when resized. So it's obviously doing the thing, but it's not doing it on initial load. All right, let's rebuild so I can see my changes in place. Beautiful. Exactly as I predicted. Ah, we're still losing that though. Still losing it there. And it's not 100% either. Okay. Let's bring on. Oh, we edited that height. We edited the height, didn't we? Where did we edit that height? We deleted the padding. Here it is. Let's see what's going on. Let's see what's going on with this table padding. This is it. A lot of. Sorry, I'm editing the code. I'll come back to the terminal now. A lot of this is just kind of going backwards and forwards. A lot of the time. All right. So when I add back in the padding, it's clearly chopping off too much. You take it out, we're losing a line, so we need to reduce it. Oh, I need to add one. see what happens here. Let's cut it off. That was my friend Roger. My friend Roger. Look, I'm in the Go code. And what I've done is just chopping this down a little bit so we can get that. I'm going to go back and take a look at the search in a minute and see how well the search is doing. But we can't really start testing out search until we've got more of the UI kind of bits and pieces we need. We'll start adding in a minute, but I want to make it look and feel just a little bit better. We'll do that. All right, I'm going to run this. I'm going to run it. Cutting it in half is still giving us still one line off, so it's off by one. It's off by one. All right, let's cut it in half and off by one. I don't think we need to add a board around that table. Do we? So we are off by one. All right, we're off by one. We'll come and figure that out a little later, but at least we've made a better note of it, and this should now give us the experience that we're looking for. Yeah, there it is. Perfect. Perfecto. And it's actually put the columns in the right place. Why is that? Okay. Okay, so watch this. Columns in the wrong place. Bring up the split view. Columns in the right place. Columns stay in the right place. That's the next challenge for the LLM. And then we can let's fix that. We'll fix that, and then we'll put some what we'll do. Actually, I like to take some lunch. I'm hungry. Well, we'll see. We'll see. I'm going to go in 3.5 hours. Yeah, feeling a bit hungry. I was actually planning on pausing the stream while I took lunch instead of making you sit here and wait. Oh, I would just leave it out. Who cares? I was watching anyway. And fast forward. Okay, this is in a place where we can hand it over to the old mate Claude. That is the wrong one. That is the right one. Okay. Okay, Claude. It's all looking good. However, I've noticed a bug. When you first load the TUI and you scroll around, the table is actually loading the columns all bunched up to the left. When you hit the return key and the split view comes up, the columns actually are pushed out to the right, so they look correct. And when you remove the split view, the columns are back in their right place. So we have the right logic and calculations in place for making sure the table is 400% width, but it's not happening on initial boot, and it doesn't appear until we either resize the window or we hit enter and we re-render with the split view, and then it's fixed from that point on. Can you take a look at this and find out where we've missed that initial render, and then solve it so it always comes up the right length? I'll attach a couple of screenshots for you. Let me do that. Let's do that. Let's do that for Claude. Let's go and do a couple of screenshots. I don't know why I brought the browser up. It's not in a browser. Why would I do that, you stupid boy? Not in a browser, aren't we? We're in a terminal. You can't take a screenshot of a terminal. Alright, yes you can. I mean, you can't take up a browser whilst you're running a terminal application. That's no good, is it? Let's build and run. We see here, this is our initial load, which is wrong. Let's take a screenshot of that. Lovely. And now, if we scroll anywhere, hit return. It's good. Ooh, split panel isn't 100% wide. Let's fix that. Well, there might be a padding issue on there. Fix this over on the right hand side is wrong. And we'll close that, and then we've got 3 screenshots now. We're showing all 3 states. All good. All good. Okay, let's go back to Claude, and let's go and tell him. One, 2, 3. Plop. Take a look at the screenshots. Oops, what have I done there? Shouldn't have done that. That was a mistake. I pressed full screen and it blew up my rendering. Oh, also, the split view panel is not 100% wide. It seems to be a bit short. Alright, so I've just given it coordinates. You can clearly see from the screenshots, the first one, initial load, columns are bunched. You enter, it re-renders, everything's correct and calculated. You resize, everything's correct. Everything's correct after that first resize. It's initialized table that creates the table, but it never calls adjust column widths. Exactly right. That is the problem. Columns only get adjusted when we update the dimensions, which happens on a re-render. 2 issues to fix. The column widths are not calculated on initial load because we need to call adjust column widths in initialized table. That is correct, Amundo. I'll pull this down a little bit. Loads of white above my head, it seems. There you go, looks a bit better. And then we need to fix that split view. The panels, they're not the full width. We need to adjust the panel width calculation because it's slightly off. You're absolutely right. Not yet. We haven't been right. We've been right twice today, I think. All right, so we're adding adjust column widths, which is what needs to happen to that initialize table function. Method, I think it's a method. Initialize table is a method. And it's going to give us the width that we need. Okay, that should have worked. Now it says that's going to fix that calculation. Table vertical padding. There's that padding again. Accounting for borders on each side. Oh, I see. I see. That's another thing to remember that's always tricky, is the borders do actually take up a line or a column when you add them. It makes everything thicker. A lot like CSS in that sense. You've got to remember your box model training. If you don't know what the box model is, you should go and look it up. If you do, but only if you do web stuff though. Box model was a huge big thing back in 2007. Okay, this is perfect. Let's fix both issues. The change has been made. Column widths now calculate an initial load, so we should have that out of the gate. And we've added adjust column widths at the end of initialize table. Now the URL column properly calculates its width based on the terminal size from the start. And the split panel should be full width because we've taken into consideration there's borders around them. So it's like 1, 2, 3, 4. It's 4 pixels, or 4 columns, sorry, that need to be accounted for. The table should now display with proper column widths from the moment it loads, and the split panels should fill the entire width of the terminal. Let's try it. Let's try it, because that's exactly how it should be, and it's exactly right. It's exactly right. Okay, let's try it now. And I do believe I've messed something up here. There it is. No, I didn't mess something up. It's just being weird. All right, that's right. Loading half file. Aha! Bingo. This is starting to look a little better. Now, let's see if they are full width. Still missing, looks like a column or two. You're missing, I think you're only taking 2 columns instead of 4. Is that 1 or 2? I think that's 2. Looks like you're missing 2 columns, Claude. Let's go back and tell him. It looks like you're missing 2 columns, Claude. Wrong, Claude. Right, Claude. It looks like you're missing 2 columns still. It still looks like it's 2 columns too short. Are you sure you accounted for there being 4 columns of borders? Because we have 2 boxes. Let's see what Claude says. Are we going to be absolutely right? Are we going to be absolutely right? Thinking for 9 seconds, orbiting. You're absolutely right. I only accounted for 2 border columns, but we have 2 panels, each with their own left and right borders. That's why it looks 2 columns short. 2 characters wide per panel. That's right. Fix it, Claude. Yeah. Alright, well, fixed. You were exactly right. I know, Claude, I know. Thank you very much for that. Playing my ego today. Appreciate it. Let's go back. Let's go back. Rebuild. Oh, yes. We are now perfect. Looking much, much better today. Much better. I think I want to add some color. I want to add some color, and I want to add some background highlighting. What do we want to do about methods or statuses? We need to add some color, but I don't want to make it look like a traffic light, which I'm already struggling with in some of the stuff I'm doing already in other bits and pieces. I tend to struggle with traffic lights. So let's, if we let's be considerate about this. And thinking, so I'm just thinking about what I want to do. How do I want to color this? I want the currently selected row to have a faint highlight, a faint background on it, so you can see that row is highlighted. Right now it's just like a pink. And then I think I want to colorize. Is everything bolded? No, everything's not bolded. I want to colorize the status. I think if we the status and the method, and only color 400s and 500s. All right, this is going to be trickier. Before we do that, I'm actually going to commit this code. I'm going to commit the code in this workspace because I don't want to break anything. This is a good place to say pause on this. Let's bring up tower. In tower, we're in HARific. Now we're going to the TUI. This is the workspace we're in. These are all the changes we've made in the TUI. As in, just let me zoom. Sorry, won't let me zoom. So I'm going to just modify these files. Deleted main. Moved main to HARific, that's right, and got rid of all of these CLI commands. We moved it all to root. Let's keep all of that. Modified HARgen, or hang on a minute. Oh no, I hope it's not reading that 500 megabyte file. It is reading that 500 megabyte file. Right, stupid. Don't do that. Don't read those files. Don't add them. Delete those. Delete. Definitely don't add HARgen binary. Let's just exclude you. Exclude you. Why are you not being excluded? Exclude this item. I don't know. All right. Cleaned up the CLI, removing the view and the serve commands, and started cleaning up the TUI rendering. Put that in there. Let's commit that code. Great. Work is saved. Let's get the next phase, which is getting these elements colored and these colored correctly, and the duration. I want that to be the same gray that we've got up here. Let's get that all done, and then we can move on to rendering these bad boys out. But I'm really going to need the agent to go and read the code in vacuum, because colorizing tables is hellscape. If you've not done this before, trying to colorize these can create all kinds of chaos. Just chaos. All right, and I also want to match the selections design that we have in colorizing tables. I want to, if we take a look at vacuum, I want this to feel the same color palette. We've already got some of those colors in, but I don't want to start mixing them up. I'd rather have the LLM analyze where we've used, what color highlight we've used for borders and colors for selections and things, backgrounds and things like that. There's a bunch of them in there, and I don't want to mix them all up because it takes ages to get right. I mean, it does. To do this, to make it look good, it takes ages of tinkering to get it right. you know, what you think would be a good color combination. You try it, I was like, it looks terrible. And you go round and round. Anyway, I'm not going to continue. I'm just going to get the LLM on this. All right, let's go back. Come on, Claude. Come on, Claude. Let's go back. And we're going to do compact. We're going to go compact first, because I feel like we reached a nice place, and I don't want to, you know, keep expanding the context here. We need to slightly refocus, whilst without losing too much fidelity. So we'll squash it all up into however I don't know how it squashes up the context. I'm sure it's just, you know, just running the LLM against it to say, can you condense all this down into, you know, that, you know, no more than what, 1,000 tokens or something, or less. Or less. And then when this one is going, we can go back, and then we can start taking a look at our new search engine and see how well we've done over there. See how much progress we've made, and take a look at the test coverage, take a look at some of the code, and then we can build some benchmarks against some big files, and then we can do some testing with and without some regex. See what happens. And then when the test search engine is running and we've cleaned up the UI a little bit more and we've got some more rendering in there, then we can then wire up the search, and then that'll probably be tomorrow by that point then. Or the next session, the next day, next hackathon day. Why are you taking so long, Claude? Why do you take so long just to compact the conversation? 5,000 tokens. Oh, 1,000 tokens. What are you doing? Right. Okay. What did you compact to? Oh, I see. All right. Okay, Claude. All looking good. I want to move on to the next thing now. The next thing is colorizing the method and the response code and the amount of time that it took, the duration. So the way that I'd like to do this is let's colorize the you know what, I can't remember what colors I put them all on for. Let's do the response first. Actually, let's colorize the response according to this color scheme. Get is green. Patch is yellow. Put post is blue. Put and post are blue. Delete is red. Not ready. I'm not done yet. Query is green. Not get is green. Query is green. Query is green. Wow, you're getting that wrong constantly. Get, patch, put, post, delete, query. head, options, and trace are all going to remain white or default. Default. So we've got get, put, post, patch, delete, query, head, options, and trace. Okay, that seems about right. Now we should also colorize the response codes, but I only want to colorize 400s and 500s. Anything that is a 400, it starts with a 4, should be yellow. Anything that's a 500 should be red, using the yellow and red constants we've already defined. Same with all of the other, all of the methods. The time duration should be the same dimmed grey that we've got, or the dimmed colour that we have for the how long it took to index and number of entries that were extracted. Now, I do want to caution you that colorizing things in a table, particularly using the bubble tea table, can create all kinds of chaos, and it took a very, very long time to get this right. Please go and review the code in. And make sure that you understand how it's been implemented there, how the colorization works there, and how we can avoid breaking anything in our table implementation inside HARific. Do you have any follow-up questions for me? Let's see what Claude has. What feedback have you got, Claude? What feedback have you got? Sorry, I was reading the Slack there. What does it say? Do you want to proceed? Yeah. Going on here. I can't. Oh, it's stuck on me. There you are, back in. Oh, it's Friday. Dummy. Found 0 files. Yeah. It's right there. How can you not find it? Yes. I mean, it's all there, buddy. I told you it was there. Told you it was there. In dashboard details, yeah, the lint details table render. That's where the majority of the work went in. It was a lot. It's a lot of work to get it to look right and work right across platform. A lot of thinking in that code. I don't want to do it again. There's the colorize table output function. Perfect, I can see the pattern now. The key insight is that don't colorize the table rows directly. You colorize a rendered output post-rendering. Yes. You do it directly, it goes mental. You've got to post-colorize it. excellent. Now I understand the pattern completely. And that was the key insight for me, really, was trying to get the rendering of the table to be right. And I mean, I wanted fine control over like rendering the paths and colorizing things like that. And I could not, for the life of me, get it to work. Could not get it to work when I was rendering inline. Like you render the row and then you put the ASCII codes in, then you try and render that, and it renders it. So you got to post-process it, like we're doing in other places. Not in this project, but in other projects we're doing it. All right, let's take a look. Let's see what we got. Perfect. I now understand the proven approach for vacuum. Here's the pattern. We build a table with plain text. There's no colors in the row data. Yes, we call table.view to get the rendered string, post-process the rendered string using strings replace, and add the ANSI color codes. We use lip gloss styles like style method get, method get. Style method get. We might need to refactor that. I don't like that. This avoids breaking Bubble T's layout calculations. Yes! And this is the reason why it would screw up, is because it calculates width based on the text characters in those strings. And if you've got endless amounts of escape codes, it gets it wrong. And it goes mental. Mental. All right, we're going to create lip gloss styles. Get query, green, patch, put post. Okay, that's fine. Create colorize heart table. Heart table output. Oh, okay. Heart table. That T is confusing. Looks like heart. Doesn't matter. It is actually right. Render table view. Get and query should use the exact green shade. There's only one. I don't want them to be different. It would look awful. And make the style definition something obvious, like style method green, not style method get. For durations, use the exact same faint style we've already defined. Let's not start adding more grays in. I want you to make sure that the table looks identical as it can in terms of the background selection colors as vacuum. So I believe we've already copied over the styles in the 2E from vacuum, but I need you to make sure on this, double check, look at it, and make sure that the tables look as close as they can in terms of when you're selected. We've got a row selected, both in the foreground and the background colors. I want them to match exactly. A lot of time went into that, and I don't want to change it. There's actually people in the office now. Actually people in the office. Amazing. It's like COVID never happened. No COVID. Okay. Right, well, we're gonna roll this for a minute and then see how we get where we end up. In the 2E diction is still not perfect, still not great, but it's much better than it used to be. You see all those colors that I put in. It took a long time to get them right. I'm actually happy with them, but it did take a very long time to get them right. You see now it's doing its thing here and taking out color blue, color green. it right. Make it right. Look, if we get the colorization in and it's reasonable, then we're gonna take some lunch. Oh, we're gonna get a sandwich. Now, let me hang on a minute. Color. Oh no, I don't want you to do that. Maybe I do want you to do that. Not really. Not really. We're gonna have to undo that. We're gonna render the split panels later. Undefined. Of course. Yeah, you're gonna have to go and replace those in the loading screen. Yeah. Loading screen's got a bunch of color in there. And then we're going to wrap the loading screen in a border. And then we're going to put some simulated time. Because we don't know how long it's going to take, but we roughly know how long it's going to take. Simulated little progress bars when they're quite dashing, and then we can also gradient it. Nothing all the way to solid pink or blue. Bringing in our color, RGB blue. That's right. Those colors, right? Oh, so long, so many hours, so long. The subtlety. When you do a background highlight, you know, if it's just slightly too light or slightly too dark. Kill Shell, what are you doing? You can't do that. You can't test it. Only I can. You cannot do that. Not unless I hook you up with a Tmux or something so you can directly control the terminal. But you can't render on an TTY, don't you know that? Alright. Perfect. The code compiled. The TTY error is expected. Yes. Got the color constants in, you've updated its table styles, you've added my colors. You know what? Let's give it a go. Let's give it a go. Let's go give it a go. Let's see where we end up. 1, 2. Oh, look at that, ladies and gentlemen. It's gone and colorized. It hasn't. Oh, well, it's done the right thing. This is right. This is right. This is right. Doesn't feel like Skittles. Doesn't feel like Skittles. It's a little Skittles. There is a little Skittles going on here. See, this is the problem. It's like, how do I want the pink header? I want the pink header. No, you know what? You know what we're going to do here. I'm going to commit Gonna commit the code, and then it's time for a break. We're 4 hours in, and I'll need a little rest. And another 3 or 4 hours after this. What I'm actually going to do is I'm going to break the stream into 2. We're going to finish this one here in a minute, and then I want to start up again in about another hour. Simply because I want to have some lunch, and I don't want to leave the stream running the entire time. So I'll break day 4 into 2 parts. Nice and easy for me. In fact, it'll probably be easier when I'm in the office to break it into 2 parts. So while we're at it, let's go to tower. And we're going to save that because that's looking good. The next thing will be, I guess, we'll go and look at the search code, and then I don't know. There's so many choices. I want to think about it over lunch. I want to think about this over lunch. What I'm going to do. In the meantime, let's save this code here. Good. Okay, so with that being the case, what I'm going to do is I'm going to end the stream here, and I'm going to set up another one for about an hour from now, and then we'll pick up at 1 p.m. 1 p.m. Pacific, 4 p.m. Eastern, and then we'll go from 2, maybe 3 hours. We'll see, maybe 2 hours. It's been a long day so far. But thank you for sticking with it so far. I'm off for some lunch. I will catch you on the flip side.